Okay, I think we're going to do the Unit 8 practice day lesson. Well, I guess there's some thinking to it. We are going to do the Unit 8 practice day lesson. So this is our last unit, at least it is for the year that I'm recording it. Yeah, let's just jump into it. This is the last official lesson of not only Unit 8, but of the year. From this point on, we're either going to be reviewing for the Unit 8 test or reviewing for the final and then taking each of those tests. So this is like our last lesson. Anyways, first thing I want to do before we really get too far into it is talk about our calculator. So on said calculator, there's a couple of different ways. So like number one wants us to do 8 factorial. Certainly one way you can do it is do 8, then hit menu, go to 5 for probability and 1 for factorial. That'll get you 40,320. Certainly one way to do this. Now, another way that you could do this is instead of having to go to menu 5.1, you could have also have hit 8 and then right beside the G on the keyboard where you see my mouse kind of moving around here, there's a key that has a question mark, an exclamation point, etc. You can hit that, get the exclamation point, and then boom, you still get the same answer. So it doesn't matter which way you do it. Number 2, ask us to do 5 factorial. I'm actually going to do the second way because I think it's faster. You get 120. So 5 factorial is 120. Kind of make this a different color so you can see it easier. And then for the next one. Now, this one, if you remember that this is a permutation, 6 would be your N, 3 would be your R. You could easily do NPR 6, 3. Let's say you didn't recognize that, but you know how to do a factorial. And in that case, you can just type it straight into the calculator. You don't need to do anything fancy. Just type it straight in like it is on the paper. So 6 factorial over, and then in parentheses, 6 minus 3 factorial. Hit enter. 120. Same thing for number 4. If you recognize this as a permutation, you could do NPR 10, 5. I think that's what I'm going to do this time because I've already shown you how we can do it on number 3. If that's what you're comfortable with, again, stick with that and just type it in like it is on your paper. But if you realize it's a permutation, then you can hit menu, probability, and then permutation, and do 10, 5. You get 30,240. Either way works. I mean, just to prove that either way works, I'll just type it in plain Jane. Wait, see, we still get the same answer. So there's that one. Number 5. Eva is shopping for school supplies. She has a choice of one of each of the following: 6 backpacks, 8 notebooks, 3 pencil cases, 3 brands of pencils, 8 brands of pens, 4 types of calculators, and 4 colors of highlighters. How many choices does she have for the school supplies? Well, let's see. Let's kind of write down what's going on here. So for backpack, I'm just going to abbreviate that as BP. She's got 8 choices. Notebook. Oh, wait, sorry. Backpack, she's got 6 choices. Notebook, she's got 8 choices. Pencil cases, she has 3 choices. Pencils, she's got 3 choices. Pens is 8. Calculators is 4. And highlighters is 4. So if we want how many total different choices does she have, then we just straight up multiply all of these together. And it's going to give us a big number. But that's still how you do it. So 6 times 8 times 3 times 3 times 8 times 4 times 4. Let me try that. 6 times 8 times 3 times 3 times 8 times 4 times 4. 55,296. Different outcomes. That's how many different ways she can pick her school supplies. That's a lot of ways for school supplies. Okay, Josh is making a stuffed animal. Maybe he's at like Build-A-Bear or something. I don't know. But he's got 10 choices for animals, 3 choices for type of stuffing, 5 choices for sound effect, 3 choices for eye color, and then 20 choices for outfit. Of course, if you've ever been to like a Build-A-Bear, you're going to get, as long as you don't want to pay extra, you're going to get to pick one of each. So one type of animal, one type of stuffing, one sound effect, etc. So that's what Josh is going to do here. To figure out how many choices, you do 10 times 3 times 5 times 3 times 20. $9,000. So 9,000 different animals. I'm going to just say different outcomes. Because he's got to pick one of each. Number 7, Valentine gift sets come with a choice of 4 different teddy bears, 8 types of candy, 5 balloon designs, and 3 colors of roses. Find the number of possible outcomes for each situation. Okay, so let's see what we have. We have teddy bears, and there's 4 different types of teddy bears. For candy, there's 8 different types. For balloons, there's 5 different types, and for roses, there are 3 different types. So to get the total number of outcomes, 4 times 8 times 5 times 3. 4 times 8 times 5 times 3. 480. Okay. Number 8, the service club is choosing members at random to attend one of 4 conferences in LA, Atlanta, Chicago, and New York. There are 20 members in the club. What's the probability that Lena, Sherry, Miguel, and Jerome are chosen for these trips? So these are 4 people right here. Those are 4 people, which if they're choosing one person to go to each conference, that means they would want to choose 4 people. So does order matter here? No, order does not matter. I'm going to actually put that in red. Order does not matter. And then can one person go on 2 trips? No. So this is going to be without replacement. So now we have order does not matter and it's without replacement. This combined makes it a combination. So let's see. We have 20 members in the club, so N is 20. We need to pick 4 people to go on these trips. Okay, so it's going to be a combination where we have 20 and we're choosing 4. So to do a combination, you get a menu, probability, which is option 5, combination is option 3. You do 20, 4. 4,845. That's how many combinations they have. Now it's asking what's the probability that Lena, Sherry, Miguel, and Jerome are chosen. This is one outcome. So the probability would be 1 out of 4,845. And then that would be your answer. Like, that's it. Okay. Okay, number 9. What's the probability that a 7-digit telephone number generated using the digits 2, 3, 2, 5, 2, 7, and 3 is the number 222 3357? Well, let's see. There are 7 digits here. So the way I could arrange this, the number of arrangements, would be 7 factorial. But over here, you'll notice we have repeats. So the 2, we have 3 2s. And then we have 2 3s. So how many different numbers could we have? Well, the unique phone numbers would be 7 factorial over 3 factorial times 2 factorial. So 7 factorial divided by 3 factorial times 2 factorial. 420, so 420. Now, it's not asking for how many unique phone numbers. It's saying what's the probability that we get this exact phone number. This is one outcome. So the probability would be 1 over 420. So that one you had to kind of think a little bit. We had some repeats. Okay, number 10. Emily is giving away part of her international doll collection to charity. She has 20 dolls, each from a different country. If she selects 10 of them at random, what's the probability she chooses the ones from Ecuador, Paraguay, Chile, France, Spain, Sweden, Switzerland, Germany, Greece, and Italy? Whew, that's a lot, but keep in mind. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, that's a lot, but keep in mind, this is one outcome. So this 20 is our N. This 10 has to be the R. Now we've got to ask ourselves, does order matter? Does it matter whether she picks the one from Ecuador first or last? No. Order does not matter. Can she pick the one from Ecuador twice? No, so this is going to be without replacement. Which means, and this N and R are all in my way. That means since Order does not matter, and we're without replacement. That means this is a combination. And our calculator, NCR 20, 10. $184,756. That's how many different ways she can pick these dolls. Now, with that being said, it doesn't ask for that. It says, what is the probability? That's one outcome, so the probability would be 1 out of 184,756. Okay, 11. Parking stickers contain randomly generated numbers with 5 digits ranging from 1 to 9. No digits are repeated. What's the probability that a randomly generated number is 5, 4, 3, 2, 1? Blast off! Again, this number is one outcome. So it's a 5-digit number. Draw 5 blanks. And our digits range from 1 to 9 that we can choose from. So for the first digit, there's 9 options. No digits are repeated. So that means we're going to have 8 options, then 7, then 6, then 5. Multiply those together. $15,120. That's how many different numbers. Now it wants the probability. What is the probability of getting that one number? Well, that's going to be 1 out of 15,120. Again, 12 and 13 ask you to use the spinner to find each probability. If the spinner lands on a line, it's spun again. So 12 asks us the probability that the spinner lands on red. Well, how many degrees are in a spinner in total? It's a circle, so it's going to be equal to 360 degrees. That means the probability that we land on red, we just need this 40 right here. is going to equal 40 over 360, which if we reduce that, that would be 1 over 9. And number 12, find the probability of the pointer landing on green or orange. Let's see, orange is here, green is there. So this will be 70 plus 80 over 360, which would be 150 over 360. Again, always reduce. I divide that by 10, that goes away, then divide by 3. So basically divide by 30. It's going to be 5 over 12. Okay, 14, I should say 14 and 15. Point X is chosen at random on LP. Find the probability of each event. (14) asks that the probability that the X is on LN. So LN would be this distance right here. Well, what's our whole shebang? If I add up all of this, what would this give me? Two plus 8, that's 10, plus 10 is 20, the whole is 24. LN would be 2 plus 8 over 24. So 10 over 24, which reduces to 5 over 12. Okay, 15. It says the probability that X is on MO. So MO goes here. It's going to be 8 and 10. This is a probability of 8 plus 10, still over 24. That's 18 over 24. Divide those both by 6, and we get 3 over 4. Okay, so I guess since I adjusted those two numbers, I need to adjust these two numbers. It's going to be 16. It's going to be 17. Find the probability that a point chosen at random lies in the shaded region. So the whole thing is my outer shape. Which this 2 right here is our radius. So that means the whole side of the square is going to be 4. This is a 4 by 4 square. So the whole is a square. So S squared is our formula. It's going to be 4 squared, which is 16. The circle that we want, the shaded area, Remember, we do pi r squared. So pi times 2 squared, or 4 pi. I'll leave the 4 pi for now, because when I do my probability, I can use the exact answer. So the circle is my shaded area. That's going to be 4 pi over 16, which reduces to pi over 4. They don't tell us how to write our answer. So I'm going to come down here and say the probability is equal to pi over 4, which is approximately equal to, let's type it in the calculator. I mean, pi. I forgot where pi is at. There it is. Pi divided by 4. 0.785. That's our probability, 0.785. Okay. So now here, the whole thing is my circle. And the diameter, well, the diameter is 12 divided by 2. Sorry, the diameter is 12. The radius is 12 divided by 2, which is 6. So pi r squared would be pi times 6 squared, which would be 36 pi. Now the shaded area is a triangle. Which, remember, our formula for that is 1/2 base times height. We cannot use this 12 as a base or a height. We have to use what's by the right angle. So yes, I have that 6, but I have to figure out what this side is right here to use as my other number, which means I've got to do the Pythagorean theorem. So 6 squared plus x squared equals 12 squared. Be 36 plus x squared equals 144. Subtract 36 from 144. We get 108. Square root that. And let's see. Let's see what can go into 108. Let's see, can 36 go into it? Because I'm wanting to simplify the radical. 108 divided by 36. It does, 3 times. So this, I'm going to split up to be 36 and 3. If I square root the 36, I get 6. I can't square root 3. So it's going to be 36 square roots of 3. That's going to be our other piece right here. Okay, so let's see. 1/2 of 6 is 3. 3 times 6 is 18. So 18 square roots of 3 is the area of my triangle. So now the probability. The shaded area of my triangle, so 18 square roots of 3 over 36 pi. 18 over 36 reduces to 1/2. So that's going to be the square root of 3 over 2 pi. That means our probability, the exact answer, is the square root of 3 over 2 pi. Of course, I know y'all are going to want to do an approximate decimal. So square root of 3 divided by 2 pi. 0.276, basically. Okay, those two were a little ugly. I'm sorry. I was trying to do the exact answer all the way down to the bitter end. Okay, so there is the lesson. It's a practice day, which means there's no guided practice. You can jump right into the assignment. And yeah, that's it. Y'all have any questions? Y'all know how to get a hold of me. And last but not least, remember, you are awesome and you are created to do wonderful things. Always believe.